Hello guys, I hope you're doing alright, and here we are in a new video about sets. And now we're going to talk about complement of a set. So we go to the PowerPoint presentation, the slide 14, and we will check the definition of complement of a set. So let's read it. Given a set A, the complement of A is the set of all elements in the universal set U, capital letter, but not in A. We can write A with a little c up like this, so it means complement of A. You can also say complement of A in U, in the universal set. So if, for example, if we have a set A that includes A, B, and C, the elements A, B, and C, and we have outside a universal set, and the universal set contains everything. Remember the definition of universal set. So the universal set contains the set A, and we have two elements outside, D and F. So if we are going to write the complement of A, the A complement, so we need to look at the elements that are outside A. So for example, D and F. So the complement of A will be D and F because they are not included in A, but they are in the universal set. Okay, so this is the definition of complement. So the elements that are not included in that particular set. So in this case we have D and F. So let's continue with the next slide 15, and here we have an example. Considering the sets A and B established below, determine the complement of A, B, and C. So let's start checking the numbers. We have A. The definition of A is X such that X is a prime number and X is less than 11, and even X belongs to natural numbers. So you have to check what is this notation. Here we have set builder notation. You have to check the last video about roster method and set builder method. And here we have the set builder. This is set builder because here we have a description. This is set builder 2 because we have X such that X is an odd number and X is less or equal to 10, and X belongs to natural numbers. So this is set builder. And we have the last one, C, and we already have the elements. We have C equals 3, 4, 5, 8, and 9. So this is roster method because here we have the elements already included. So the first one is set builder. The second one is set builder because here we have a description. And the last one is roster notation because we already have the elements. Check the last video. So first of all, we need to get the roster method of A and B. We have to get the elements of these sets. So let's start with the first one. With A, X is a prime number less than 11, and X belongs to natural numbers. So what is the set A? We include the elements of A are, what are the prime numbers less than 11? And natural numbers. So we have number 2, we have 3, we have 5, we have 7, 9, no, 9 can be divided by 3 too, so this is not a prime number. 10, it's an even number. And 11, we don't include 11 because it says less than 11. So not equal to 11. So that's it. This is the set A. Now the set B is X such that X is an odd number and X is less or equal to 10. And X belong to natural numbers. So these are numbers that include all these conditions. So we have the odd numbers less than 10, less or equal to 10, we have 1, 2, 3, 5, 7, and 9. And the last set, we already have the elements 3, 4, 5, 8, and 9. So the universal set for all of these will be, let's write it here. We have 0, no, 0 is not included here. So we have 1 from the least number, we have 1, 2 is included here, 2, 3 is included in the 3 sets, we have 5 is included here, we have 7 in A and B, we have 8, and we have 9, all right? This is our universal set. So now, let's start checking the complements. Let's start with the A complement. So, we are going to write here the elements that are not in A, but are in the universal set. So in the set A, we have 2, 3, 5, and 7. Okay, so we have to write here the elements that are not in A, but are in U. So we already have 2, but we don't have 1. We have 1 in universal set, so we write 1. Here we have 3 is in A and is in universal set. 2 is in both sets. 5 is in A and is in U. 7 is in A as well as the universal set, but 8 and 9 are not in A. So we write 8 and 9. Okay, 8, 9. We can close the curly brackets, and we already have the A complement, all right? So this is checked. Now, the B complement. How can we write the B complement? So let's check the elements that are not in B, but are in the universal set. So, in the set B, we have 1, 3, 5, 7, and 9, the odd numbers. So in universal set, what elements in U are in U, but not in B? So 1 is already in B. 2 is not in B, so we write 2. 3 is in both sets. 5 is also in both sets. 7 is here too. 8 is not in B, so we write 8. The next one, 9, is also in B, so will not be included in the complement. So that's it, these two elements. And the last one, we are going to check the complement of C. So in the complement of C, the same procedure. The elements that are not in C but are in U. In universal set, we have 1 and is not in C. So this is the first element of the C complement. So we write 1. The next one, 2 is not in C. So we write 2. 3 is already in C, so we don't include 3. 5 is also in C. 7 is not in C, so we write 7, comma. 8 is also in C, and 9 is also in C. So that's it. This is the C complement. All right? So here we have the three complements. A complement, B complement, and C complement. All right? So this is the first part. We already know how to get the sets in roster notation. This is very important. If we have the set builder, then first of all we need to get the roster notation, and then we find the universal set, and finally we can get the complements. So let's check other example. Something like this. So let's erase this part. Okay, now this is the example. We have given the sets A, X includes the elements from 2 to 8, and they are natural numbers. Now, first of all, we need to write these elements in roster notation. So we have, it includes 2 because here we have the equal sign, and it includes 8 because it has equal sign. So we have 2, 3, 4, 5, 6, 7, and 8. Close curly brackets. And the same with the set B, we represent this set in roster method. So X is an even number less than 12. So it includes from 0, 0 is an even number 2, 2, 4, 6, 8, 10, and 12 also. How can we get the complement of A? So the complement of A will be the elements, no, first of all, the universal set. The universal set includes all the elements in A and also in B. So here we have 0, 2, 3, 4, 5, 6, 8, 7 also, because 7 is in A, 8, 10, and 12. So the complement of A, let's check the elements that are in the universal set, but are not included in A. So for example, let's check one by one. So 0 is in universal set, but is not in A. So the first element will be 0. The second one, 2, is already in A. 3, already in A. 4 is already in A. 5 is in A. 6 also. 7 also. And 8 also. So the last elements, 10 and 12, are not in A. So we include 10 and 12. Okay? So this is A complement. And the last one, B complement, the same procedure. You are ready to do it. So we have the elements that are in universal set but are not in B. So one by one, here we have the same procedure. 0 is in B, 2 also, 3 is not in B, so we write 3. 4 is in B, 5 is not in B, so 5. 6 is in B, 7 is not in B, so we write 7. 8 is in B, 10 is also in B, and 12 is also in B, so that's it. This is the B complement. So here we have, guys, it's very easy. We only have to write the sets organizedly and always build the universal set. If we have the set builder like this and like this with the description, we transform into roster method with every element, and then we build the universal set. Once we have the universal set, we can get the complements, all right? So that's it. I hope you understood, and see you later. Bye bye.